Hello everyone, today our discussion will be on discovery of neutrons. In our previous tutorial class, we have discussed about the discovery of neutron and electrons. Now we are going to discuss about the discovery of neutron. So Chadwick, he discovered neutron. So for easy understanding, let us consider hydrogen atom, helium atom. These are not given in your textbooks. For this is just for easy understanding. So hydrogen atom has 1 proton and helium has 2 proton. So it was found that when hydrogen atom and helium atom were weight, it was found that helium was heavier. So since helium has 2 proton, so 2 hydrogen were added, and then the weight was taken, and then it was still found that helium was heavier. So here 2 proton and 2 proton, but helium was heavier. And another example is lithium. So atomic number 3, but AMU is atomic mass unit is 7. Beryllium 4, but atomic mass unit is 7. So the number of proton is 3, 4, but atomic mass unit is higher. So something must be contributing to the mass of these elements. In our previous discussion, we have discussed about the discovery of electrons and protons. Electrons and protons, they contain charge, but there must be something or subatomic particles, which is neutron. So scientists thought that there must be something. So Chadwick, he experimented using alpha particles, a beryllium sheet, paraffin wax, and then a detector. So these alpha particles are helium nucleus, atomic number 4, number 2, and mass number 4. So they have +2 charge, or 2 plus charge, So alpha particles, he bombarded these alpha particles, from a source, to a beryllium sheet, and what he observed was a certain kind of radiation. So this radiation, these radiations does not have any charge, positive or negative charge. So this radiation struck upon this paraffin wax, and protons were released. So protons were released and they were detected by the detector. So he thought that this neutral particles, they must have a equal size or weight, similar size or weight to that of the protons. That's why when these alpha particles were bombarded, this neutral particle hit this paraffin wax and release the proton. So a smaller particle could not release the proton because they are smaller, but these neutral particles, they hit this paraffin wax and release the proton. So he thought that these neutral particles must have similar mass to that of protons. So after this, he calculated and found out the mass of neutral particles, and he called these neutral particles as neutron. So it has a mass equal to 1.674927 into 10 to the power 27. So they have mass little bit higher than the protons. Okay, so with this we come to the discovery of the subatomic particles, electrons, protons, and neutrons. So this is a table, okay, showing the symbol of electrons, their charge, okay, the absolute charge, relative charge, their mass, okay, mass, atomic mass unit, approximate mass, and discoverer. Electron represented by this symbol, okay, absolute charge is 1.602176 into 10 to the power 19. Relative charge, okay, taken as -1. Mass, okay, is mass per kg is 9.1098382 into 10 to the power 31. Okay, and atomic mass, okay, mass 0.0054. okay, so approximate mass is 0 for electron, okay, and proton is given here also, represented by P, and then the charge is plus sign, okay, so approximate the relative mass charge is plus, and then approximate mass is 1. Okay, neutron and there is no charge for neutron. Relative charge 0, okay, since it is neutral, and then approximate mass is 1. Okay, so discoverer of electron J.J. Thomson, proton Goldstein, and neutron Chadwick. So this is given in your textbook also, this value, okay, so remember this value, okay, this value in their mass and even the charge, okay, try to remember these values. Okay, next topic is atomic models. So in atomic models we are going to discuss about J.J. Thomson, Ernest Rutherford, okay, Bohr's medal. So this discovery of subatomic particles, electrons, protons, neutrons, okay, after this discovery, okay, there were many challenges faced by scientists. Okay, those challenges or those problems were to account for the stability of atoms, to compare the behavior of elements in terms of both physical and chemical properties, to explain the formation of different kinds of molecules by the combination of different atoms, okay, to understand the origin and nature of the characteristics of electromagnetic radiation absorbed or emitted by atoms. Okay, so these are the challenges faced by the scientists, okay, after this discovery of electrons. So these were the challenges, okay, and faced by the scientists to explain, okay, these problems. Okay, now J.J. Thomson model. J.J. Thomson model, okay, so from this model he proposed that an atom, okay, possesses a spherical shape, okay, a radius up to 10 to the power minus 10 meter, okay, approximate radius, okay, of the atom, okay, 10 to the power minus 10 meter. So he considered this sphere to be a positive charge, okay, so this sphere is positive charge, or this cloud is positive charge, okay, and the electrons are embedded, okay, uniformly, okay, or uniformly distributed in this sphere of positive charge, okay, electrons. The electrons are negative charge. So this model is also known as Plum-Bardeen resin bonding or watermelon model. So this look like a plum, okay, plum pudding or resin pudding or watermelon model. Okay, let me take an example of watermelon. Suppose this is watermelon. Okay, so if you cut, okay, the watermelon, you can see inside seeds are embedded, okay, inside the watermelon. So let's just consider these are positive, okay, positive sphere, okay, this is positive sphere uniformly distributed, and these seeds are electrons, okay. So for easy understanding you can consider it like that. So this theory was able to explain the overall neutrality, okay, of the atom. So an important factor, okay, important factor of this model is that the mass of the atom is assumed to be uniformly distributed, okay. The mass of the atom is assumed to be uniformly distributed over the atom. However, this theory does not give explanations on nucleus, okay. It does not talk about the nucleus, okay, or whether the charge, okay, are static, fixed or moving, okay. Whether these electrons are static, fixed or moving is not explained, and this theory does not provide any experimental evidence. So our next topic is Rutherford's nuclear model of atom. So in this model, okay, this model consists of a source, okay, alpha particles. We have discussed later also, before also, okay, not later, before also in Chadwick experiment, and lead plate and photographic plate, okay, circular photographic plate and thin gold foil, okay, sheet. This experiment is also known as alpha particle scattering experiment. So according to this model of atom, okay, Thomson considered the gold, okay, for atom to be of evenly spread, okay, evenly spread, and alpha particles, okay. So evenly spread gold sheet and alpha particles, okay, when they hit, okay, they might deflect, okay. Is suppose those seen, and then he carried out his experiment. So what he observed, okay, when he carried out his experiment was, so he bombarded these alpha particles, okay, through a lead plate, okay, and it struck the gold foil, okay. So the alpha particles, okay, they penetrated, okay, through the gold foil and hit the photographic plate, okay, and you can see this, okay. When this alpha particle hit this photographic plate, a flash of light, okay, was observed through this photographic plate, okay, indicating that the alpha particles penetrated through this gold foil and hit this photographic plate. So most of the alpha particles, okay, they penetrated through the lead plate and, okay, this gold foil and struck the photographic plate, okay. However, a small fraction of the alpha particles deflected, okay, by a small angle. a very few alpha particles, okay, bounce back. Only very few alpha particles bounce back 180 degree. So here is a schematic, okay, view of the gold foil and the beam of particles, alpha particles striking the gold foil. Okay, so most of the alpha particles penetrated through the thin foil, and then some deflected a bit through a slight angle, and some deflected back, okay, 180 degree. So only few deflected back 180 degree. So what were the conclusions, okay, we drawn from these experiments were, so after carrying out this experiment and after observing, okay, he made these conclusions. Most of the space in the atom, okay, is empty, okay, as most of the alpha particles pass through the foil undeflected. A few positive charges written in short form of alpha particles were deflected. The deflection, okay, must be due to enormous repulsion force, showing that positive charge of the atom is not spread throughout the atom as Thomson has presumed. So as we have discussed before also, positive they repel. So in the first point we have discussed most of the space in atom, okay, so most of the space in atom is empty, okay, and the deflection must be due to enormous repulsive force, okay. So the alpha particles were, okay, according to this experiment, this space is empty, that positive charge of the atom is not spread throughout the atom, okay, as Thomson has presumed. So the positive charge are concentrated here in the nucleus, okay. So when the alpha particle pass, okay, few of the alpha particle deflected back 180 degree, okay. So there must be a positive charge, okay. Alpha particles, they are positive charge, okay, remember that. Then deflected back 80 degree. That means they are not distributed around the in a sphere as Thomson has proposed. The positive charge has to be concentrated in a very small volume, okay, in a very small volume, that is nucleus, okay, volume that repel and deflect the positively charged alpha particles. Calculation by Rutherford showed that the volume occupied by the nucleus, okay, is negligibly small as compared to the total volume of the atom. So the volume is very negligibly small. The radius of the atom is about 10 to the minus 15 meter, while that of nucleus is 10 to the power minus 15. Oh sorry, it is not minus, okay, this minus 10 and this is minus 15. So as just imagine taking an example of a cricket ball and the radius, okay, of the field, okay. So if you take a ball and then taking the radius of the field, okay, so the distance between the ball and the radius of the field, okay, taking 5 kilometer, okay. So how small, okay, will be that cricket ball, okay, if you take 5 kilometer, okay, as a radius of the field and then cricket ball, okay. So it will be like this, okay, the nucleus as a ball and the field, okay, 5 kilometer apart, okay, as the atom. So atom is very big and nucleus is very small compared to it. So after these conclusions, he proposed a nuclear model of atom. Okay, so according to this model, the positive charge and most of the mass of the atom was densely concentrated. Okay, positive charge and most of the mass of the atom are densely concentrated in a small region. Okay, this small portion of the atom is called nucleus. Okay, the nucleus is surrounded by electrons that move around the nucleus with a very high speed in circular paths called orbits. So he said that the electrons, okay, move around the nucleus in a circular path called orbits, like the planet revolve around the sun. So next point, electrons and nucleus are held together by electrostatic force of attraction. Okay, so protons or nucleus, okay, nucleus has both positive and neutral, okay, neutral charge. Okay, so this positive charge and the electron, okay, there is attractive force between them, so we call this as electrostatic force, okay, of attraction. So these are the drawbacks of Rutherford model. You cannot explain the stability of atom. Okay, so we'll come to that, why he could not explain the stability of atom. So he considered the nucleus, okay, to be surrounded by electrons that move around the nucleus with a very high speed in circular paths. Let us consider this as the nucleus, okay, and electrons, okay, revolving around the nucleus. As said before, there is electrostatic force, okay, of attraction between the electron and the nucleus. Rutherford, he assumed that this force, okay, this electrostatic force, okay, exerted a kind of force, okay, which accelerate, okay, the electrons, okay, to move around the nucleus. Okay, this electrostatic force, okay, accelerated or exerted a force, okay, and that is why this electron move around the nucleus, like the planet around the sun, Earth. Okay, so there is gravitational force of attraction between the Earth and the sun. Okay, due to this gravity, okay, gravitational force, okay, this force, okay, gravitational force exert a force on the Earth, okay, so the Earth moves around the sun, okay, due to this force, okay, and this force, okay, in physics we call it as centripetal force. Okay, like you take a rod, okay, or thread, okay, and tie the ball or stone, okay, and you spin it, okay, and it, okay, revolve, okay, so it will come to a stop, okay, when you stop moving it. Okay, so when you apply force, okay, it will move in circular path. Okay, so it will move in circular path and it will not come, okay, at the center, but it will move away. Okay, so the Earth, okay, it is moving, okay, around the sun or revolving around the sun due to gravitational force. So Maxwell must Rutherford must have thought that this electron, okay, revolve around the nucleus like that of the planet around the sun. but Maxwell, okay, according to Maxwell theory, okay, charged particles, write in short form, charged particle positive or negative, okay, particles when accelerated, okay, when accelerated emits, okay, radiation and loss energy, okay. So when charged particles they accelerate, okay, when they move, okay, they lose or they emit radiation and lose energy, okay. So it will take for electrons, okay, to lose energy just within 10 to the power minus 8 second, okay. So within very short time this electron will lose its energy and, okay, collide with the nucleus, okay. But we know that atom is stable, okay. So this theory could not explain the stability of atom, okay, since electrons are charged particles, okay. They when accelerated will lose its energy by emitting radiation and they will collide, okay. After revolving they will collide with the nucleus, okay. So this does not explain the stability of atoms. Earth, we know the Earth is not a charged particles, okay. So we could not explain the stability of atom. Next point, this model says nothing about the distribution of electrons, okay, how electrons are distributed around the nucleus, okay. This model does not says, okay, anything about the distribution of the electrons around the nucleus and the energies, okay, of the electrons. So from the next video we will discuss about the more models of atom, okay. So more models of atom, okay, and then that will give us light about the structure of atom. And please note that the subatomic particles, okay, does not only consist of electrons, protons or neutrons, okay. It has, okay, more subatomic particles, okay, apart from those three, okay, and like positron, mesons, okay, but those things you will study in your higher class, okay, if you go higher. But not for now, we are discussing what has been given in your textbook.